Okay, so the next question that we have on the menu today is asking us, what in the world is an arc length? Okay, so arc lengths are typically associated when we have circular things or curved lines. Okay, so let's see if I can get a circle here. Circle. Cool, nice circle. Okay, so if this is the center of the circle, the arc length is given certain bounds. It's like, well, the length of the arc. So I I know that kind of sounds ridiculous, but it'd be a lot more clear if I draw this out. Okay, so suppose that we have a situation like this. Here we have our angle. This distance from center to edge is going to be the radius. The arc length is going to be, in red pen, right there. So this is the arc length. And this is typically represented with S. We don't use A, R, or R is used for radius, and we're not going to use A because that would be way too easy. It's more like because A is commonly used for other things, but yeah. So so this is what the arc length is. So if you were asked a question like, if this angle is, if you're given a certain angle, what is the length of its arc? Well, to calculate that, you would be, so if we say that given angle, find arc length, you would just do angle over 360 degrees multiplied by 2 times pi times radius. Okay, so this would be your S of theta. The reason why this works is, well, this is going to be this term. This first term is the percentage of full circle, and this here is circumference. So hopefully it should be hopefully clear from the diagram here that the arc length is going to be some fraction of the total circumference of a circle. For more, I guess, complicated curves like ovals or waves, we're not really going to worry about arc length that much, but if you know the total circumference, which has got to be 2 times pi times r, that's the definition of circumference. If we know the angle, well, we just take the percentage of that and we can find the corresponding arc length. Now, a good relationship between arc length and radius and theta is as follows. So theta is equal to arc length over radius. Okay, and this is the angle in radians. Arc length and radius. Okay, so this is like the definition for radian angles. And this is extremely important. You will use it in quite a few different areas of mathematics as well as engineering and science. Radian knowledge of angles is very important. Now, I'm going to give you some secret sauce on a great way to remember this is you want to think of an eye, right? So, this like tear duct that we have that, it cries tears when we're having sad times. Let's not draw that tear because we're happy right now. And, if we have an eye like this, so this could be represented the S, the arc length. this tear duct, kind of like, you know, the theta symbol, angle in radians, is going to be there. And the circle in the pupil of the eye is going to be the radius. Okay, so I like to think about an eye to do this, because like just from the eye you can see that like this is equal to eyebrow, which is S, over circle, which is corresponding to R. I feel like that's how I remember it, is I just think of an eye and this tear duct. Okay, so yeah, it's sometimes it's great to kind of look for external objects. Like I always have my eyes with me; they're kind of attached to my head. So having things attached to you and trying to like conceal equations inside of them, it could be definitely be a useful thing. Especially like, you know, if you're in a pinch on a test and you're trying to remember, oh, how do I find the radiant angle if I know the arc length and the radius? You know, you just think, oh, well, pull out my eye, think about it. Yeah. Okay, so it's quite useful. Nice. And yeah, so that would be that. So the above solution is good.